All right, let's look at a question. So, cool, that's not too bad. Now, like I said, the idea is that, okay, well, often we're giving it in terms of time, but they can give you some information in terms of x as well. And like over here, they don't even give you the trig component of it, and that's like pretty common for some of these questions. For some of them, you do want to assume that you can just have this trig function. Some of them you don't even need the trig function, so you just kind of have to practice a few and see what the right approach is going to be, depending on the information that you get, right? So here we're given some acceleration is equal to this. X double dot is negative 4x, and we want to find kind of the same sort of properties, and we're also given some initial values over here, right? So the interesting thing about this one is, well, and where do we start?
Take the integral to find the velocity equation and sub in.
Yeah. So you want to integrate this guy? Yeah. So just be careful, because remember how I said that we can often write the acceleration in terms of x? Yeah. You can do that, but if you're sort of integrating this, that's not really the same as integrating these, because that's in respect to time. Yeah. So just sort of be careful about integrating this straight up. You could do that, because then you're going to get it in terms of x. But you can't then use these properties. So the idea is you kind of want to find a relationship between these two kind of things, right? And the trick that we're going to have to use is there is something that's in common between both, right? If you look at them, the n values here are the same, yeah? Right, so you can see that the n, that constant there, is kind of kept between whether you have it in terms of x or whether you have it in terms of t, yeah? So how can we find the n value here? It's just 2, right? Because you have x double dot is equal to minus 4x, which is just equal to minus 2 squared x, so therefore n is equal to 2, right? Okay, so then how can we use that? Well, we can use that to then form our displacement equation, right? Or we can start to form it at least, because we have actually some initial information. So you can see how like we're going to start to make the link between these two, right? So we've got, since it's in simple harmonic motion, so since it is in SHM, right, we take x is equal to our general equation over here. And actually, you can also see it's starting at the extremity, right? So it's starting at 3. So that's why I would also use cos over sine. So x is equal to a cos nt plus alpha. And then, what did we find? We did find n, which was 2. So we got that. Now, I should have said, we can't actually assume it's starting at the extremity. Like, we use cos typically to model it. It might not be starting at the extremity straight up. So, yeah, I probably shouldn't have said that. Disregard what I just said at the end. All right, so that's one equation. Anything else we can do with that? Say that again? Yeah? What are you thinking?
Well, it does got v there.
Yeah, right. So another thing you want to think about is that why do you want this in terms of t anyway? Like if you're starting out with, and if I just taught you that we can write things in terms of x, why are we kind of going back and forth? Well, again, it always depends on the information that you're given, right? We can't do much if I don't know how to relate these kind of variables, so like the acceleration and the x. Like I'm not given much information about that. But what I am given is that what's happening at t equals 0. That's why I want this in terms of t. So that's something you want to kind of look out for, right? So once I have that, what I can do is I can differentiate. I can also substitute this information in, right? So at t equals 0, x was equal to 3. So you can say 3 is equal to what, a cos, well, that's just 0. So a cos alpha, that's pretty nice, isn't it? Right? Unfortunately, what do I have here? I've got two unknowns in one equation. So we are going to have to create a second equation. I'll make a note of that one there. Right? The second one, let's take the derivative, right? So what should we use? Let's use this one. So I want to find x dot, my velocity. So that'd be the derivative of this guy. And we know that, that's just negative 2. Am I doing that right? Sine. What can we do with this though? Yes, that's it, Angus. Yes, so at t equals 0, v is equal to minus 6/3, which is a weird number, but that's a bit of a clue for you in which direction you head. So at t equals to 0, v is equal to minus 6√3. So, well, the velocity or x dot. So minus 6√3, maybe I should write x dot v here, is equal to minus 2a, and that's going to go away, sine alpha. Now, we have a second equation. I'll give you a bit of a hint in terms of what we're going to do with this. It's simultaneous, right? But just to make this a little bit nicer, I can divide both sides by 2, right? But then where can we go from there? This is the second equation. So we've got two equations, 1 and 2. How can we kind of bring them together?
Yeah, it's combine using A.
What do you mean? Oh, as in you made A the subject? Or, yeah?
Then you get to that, what's it called? Is it auxiliary?
Oh, okay.
Yeah.
And if you use that identity or?
Fuse them together.
Right, okay. Let me know what you get. There is another way, which I would say arguably might be a bit easier. Have a think what options you might have. How do you normally solve simultaneous equations? Would that work in this case? Or what other operation might you want to do here?
Yeah, I don't really remember the identity. So. Yeah.
Yeah, that's why I tend to avoid auxiliary if I can. So.
That's alright. That's why I trust the calculator.
As a clue, right? Think about a different operation. Usually we rearrange things, make things a subject, or usually add and subtract equations. But typically we don't want to add and subtract equations for trig, right? Because then that kind of poses some problems. You have to use auxiliary or other things like that. What other options do we have? Apart from addition and subtraction. Right, how might that help with these two equations here? Considering that you have two sort of trig functions, right? If you think about multiplication or division, which one of those kind of make things easier? In fact, what are you trying to do? Like, think about elimination, right? In elimination, you want to remove a variable, yeah? So how could you potentially remove one of these variables using those operations?
Divide, so A is just 1.
Right, so when you divide them, what you can do is you can realize actually these A's will divide through. So I won't have to worry about that variable anymore, right? So I'm going to pick a particular one. I'm actually going to do 2 divided by 1, which you might see why in a second. Because if you do 2 divided by 1, that's going to be minus 3√3 on 3 is equal to, yeah, you got it. So sine alpha over A cos alpha. And then what did you say that becomes, Angus? Our tan function, right? So up here, we've got, these are going to cancel out too. So minus √3 is equal to, these A's divide through as well. Minus, yeah, so tan alpha. And then, well, tan alpha is equal to √3, which is why this was such a wisely picked kind of value, constant. We've got tan alpha is √3. So alpha is equal to, is that value? It's part of 3. Yeah, the same answer?
Yep.
And how many lines of working was that for you?
That's funny, I've got to jump on memory a bit.
Take the seat, right?
Got the auxiliary right on the first time.
That's good, that's good, that's good. That's what we want to see. Have you actually answered the question there? What's the question after all that? Write the finance period, amplitude and displacement. We should probably write all those out. So we've got our... yeah, can you find that? Okay, so we've got our... or we could just substitute it into one of these, right? So sub... Which one do you guys want to do? One or two? Sub alpha equals to pi on 3 into 2. Yeah, why'd you pick that one? Equals to minus a sine of pi on 3 is going to be exact values.
I tricked you, I'm doing it into number 1.
What? You dogged it.
Yep, close.
Well, someone else can help me out this one. Sine pi on 3? No tricks there.
Wait,
Is it 6?
Yes, good man. I love it when you don't have to use a calculator to do that.
yeah.
That's what I was waiting for.
I was trying to keep the beginning.
And so what's a going to be equal to here? 6, yay, nice number. Okay, so amplitude is 6. What was we meant to find? Period, so period is equal to 2 pi on n. So 2 pi on, our n values over here, which we found actually way before, that's fine. So just pi, yep. And our final equation is going to be x is equal to, over here. So we've got 6 cos 2, n is equal to 2, plus my alpha was pi on 3 over here. So we've probably box these up. Okay. Plus pi on 3. Cool. Any questions with that one? So,
Yes.
many cool. Sorry? Why is it still n? To t? Yeah, thank you. Now, yeah, so I guess like, can you see how these questions don't exactly direct you where to go, but you just have to combine your knowledge of all the different properties related to simple harmonic motion together. I'm going to show you some questions that sort of extend that a bit further on Friday, how they can make these a bit more difficult rather than just finding amplitude, period, and displacement. What kind of situations can we actually apply this to? I do just want to finish off with one thing that I need you to do for me. So the exercises that are relevant are 7.02 from Maths and Focus, and then 6B and 6C from Cambridge. Now, why Cambridge splits it up is because they split up simple harmonic motion with respect to time and then with respect to displacement. So if you want them isolated, then you can go to Cambridge because it'll just give them to you separately. You don't have to think about it. But if you're okay to practice them together, Maths and Focus puts them all in one exercise. Most of the other textbooks do as well. One last thing I need you to do for me is that what we didn't get to look at was simple harmonic motion about, oh, right, things are on. Simple harmonic motion about x is equal to c. So,
Like a plus C on the end.
yes, so it's not about the x equals to 0. So I need you to, these are the properties here, which you can note down, but I actually need you to prove why that works. And you do it in the same way about the origin that we just did, but that proof I'll leave for you to do. So just write down this guy over here, maybe this side over here.
X equals C, then X minus C should be 0.
X doesn't equal to c. Where's that?
But X equals to C.
Oh, right. about x equals to c.
Wait, what's it talking about? What's that mean?
It's just think about it like that. About c is It's not saying x is equal to c. It's saying about the x value of c. No, yeah, right. Does that make sense?
I'm just going with C for now.
Yeah, about c. Yeah. So this guy here, probably better to write it as a cos nt plus alpha plus c, right? Because that's how, when you think about it, that's how it shifts about its values, right? You shift it up and down, right?
Is that what they want us to show?
Yeah, so can you show that this is in simple harmonic motion? I'll leave that for you for Friday. I'll note that down. Does that question make sense? So can you show that this is moving in SHM, simple harmonic motion? So this is the equation if it was shifted up and down, so not the center of motion at x equals to 0, right? Can you show that this is still in simple harmonic motion using our conditions here? So
How do you make it a question?